So firstly, how you were talking, while addressing as well, you mentioned about the 2 nanometer must be fabbed in India. You're looking forward to it as well. So my question to you is, sir, that how the government is linking 2 nanometer, basically, the chip technology with the India AI mission so that it directly benefits, you see, the India's AI infrastructure and the local server manufacturers. And also adding to it, sir, how are we trying to look forward to it that this also, the technology that's getting developed here, as you said, end-to-end has been done in India. How are we looking forward to it in the defense sector as well, how that is going to benefit?
These are more than 2 questions. Anyways, so thanks a lot. I'll try to frame it in a... So when AI data centers are getting set up in India, one direct consequence of that is now people want to start the AI server manufacturing facilities in India. Already 2 companies have come which want to, in the coming months, the announcements will be made. So far we cannot announce the names, but 2 companies want to set up reasonable sized AI server manufacturing facilities in our country. That's a direct result of the data centers coming up in India. Simultaneously, the board and the card design and the entire motherboard and the other cards which go in a server, that manufacturing will also take very rapidly, because as part of the electronics component manufacturing scheme, there are units which are going to manufacture the most advanced PCBs in our country. And once the PCB manufacturing starts happening, then the PCB assembly, which goes straight into a server or a machine, that becomes a direct outcome of having the PCB manufacturing in our country. So if you look at the entire thing, it's a very step-by-step, very clearly defined, thoughtful way of going forward. On the now fabrication side, we started with 28 nanometers, very well understanding that this is very important node, because more than 75% of the chips used in automotive, telecom, power management, industrial applications, they all use 28 nanometers to 180 nanometers, that particular entire range, the legacy nodes as we call them. Now, and it's a very, as we all know, it's a very, very complex thing. This small thing has 20 billion transistors. It's like writing the entire Mahabharat, writing the entire Ramayana, and writing the entire, all the Purans on this small little chip. That is the level of complexity, and that is the level of fineness. When we say 2 nanometer, how do you understand what is 2 nanometer, right? So this is the complexity of manufacturing. So when that is the level of complexity, then we have to go step by step. So that's why we decided to take first step as 28 nanometer, understand that full technology, learn how to walk before running. So, and that experience, that learning curve is now getting absorbed in our country. Next level should be 7 nanometer. So we have defined the path to 7 nanometer very clearly. We have learned from so many other countries who have taken this path. Japan has done this path, South Korea has done, Taiwan has done. So we have learned how these countries moved from the legacy nodes to the advanced nodes. And we have defined a path for 7 nanometers, which will be part of the Semicon 2.0.
If you like the video, do like, comment, share and subscribe.